Okay. Thank you for coming at 2 p.m. So this is going to be a big challenge that David addressed to me about talking about something very new. So, and of course, I could have been talking about the other buzzword would be deep learning, but it would be not enough new, probably. So I'm talking about deep learning in probably the end, but at the moment I will talk about blockchain. So blockchain is an incredibly hot topic in any area, and I will try to show that there is something to say also for the CAMDA community and for whoever in this room has been working very hard to develop and what is possibly the best, say, coping with the problem of reproducibility. So many people in this room have been trying to build layer after layer ways for keeping things together that can be shared with other person, that can be create a common knowledge. So that's a terribly long-standing challenge, and it is interesting to note it is something which is for us, for the scientific community, but also for our funding body society, for the publisher, and of course for the pharma industry. So it's a crisis that is affecting everybody. It's essentially a system inefficiency. Along my talk, I will try to come back more and more time about the concept that we are talking about a systemic problem and we need a systemic result. So what I will try to present is something which is really new as an idea, is to use blockchain, and I will explain what is this technology, at least on a surface level, for being constructive in creating incentivation frameworks for scientists. So we need to find a way for rewarding whoever is working very hard to create reproducibility. I think together with my colleagues, we think this is still missing. And so we are building a mechanism. And this mechanism is, on the contrary, what you would expect, it must be trustless. So something in which you don't trust people, but you trust the system. And the point that the system is not a real institution, it's a digital institution, and you want to have a warranty that you will have a permanent access, information, reproducible results, and it happened to also to produce other byproducts, so ranking reputation. So I need to spend one first part of my talk to tell you how we reached this point. And so essentially, I will start from a couple of horror stories in, let's say, in bioinformatics. Some of you may already know very well them. Some of you, for others, will be new. And also, we learn some lessons by working, especially in the MQC community, but also by other work. And essentially, we have seen in these years the development of rules first, and then of frameworks for organizing the system. And now we have the FAIR principles, which is an overall comprehensive way for managing the development, but still, we will see is not enough. So I don't know how many of you remember this guy who is smiling, Keith Baggerly. And but he was the main character together with Coombs in a very, very important story for our discipline. So the story is that Baggerly and Coombs could not replicate results from a paper, from a series of papers, from a very relevant Duke University team. There was a PI, a junior PI, was extremely prolific. He proposed a method. This method was moved along a number of studies, and then what happened is that Baggerly could not find whatever was promised in one of the first figures in the paper. And then they started inquiring, and they had very, very obscure, very deflective responses, both from the PI and from a very important journal, one of the major journals in the area. So they decided to go ahead and test it many ways, and just found out that there was a mix-up. There is something very stupid happening. But this error propagated to a number of papers. So what is important to understand, there was a connection, there was a network of damage that arrived touching very junior and bright fellows, excellent scientists, both below and above the guy. It was even found to have falsified ECCB, and that was the first excuse that was made the Duke University suspending the 3 very important trials. So there were women that were being treated using wrong assumptions. So a number of 11 papers eventually was retracted. And there are, I know of about 10 legal initiatives, a big grant revoked, and the PI eventually resigned. So the story is actually, you know the story about the 6 degrees of separation? So actually arrived even in my lab. So at one point we were developing a paper with a good friend in Barcelona, and we had this data set. We had been working months. This data set was within our, let's say, cross-validation runs, and eventually this retraction came out. We were about submitting the paper, and I had to write to my friend that just came out. So we had to stop everything and rebuild, which was better than sending out a paper with wrong data. So what is interesting, what I want to take out from here is that there was a number of debates, and the debates involved very senior scientists that had to appeal to the NCI director, because these were NCI funded projects. So they said that we have reviewed, we know the people that have been reviewing, there were errors, we are unable to understand the scope of these errors, so we urge that these clinical trials have be suspended. And then they also ended up saying, but we also have suggestion, important suggestion. At the time, I would say that was pretty strong. So we are missing detailed data annotation available for review. Any provenance, so any manipulation on the data, so provenance and let's say the tracking, what happened to the data should be clarified. And we also want a computer code. So we also want to have a complete knowledge of what has been doing and what we should do. Okay, so that's one first part I would like to point to you. In the second part, I also had the luck in this case, in case of being part was a nice paper led by Ioannidis, in which a systematic review of 1 full year of nitrogenetics for papers related to microarrays. And the trick was just replicate the first table, the first picture, the first figure. And eventually that came out to be much worse than expected. So I would call, let's say, repetition, because we would reproduce the data from the author's data, was feasible only in something less, something more than 10%. So 90% of the papers, let's say, 2 teams of scientists with some skills working enough time couldn't reproduce. So the inability of reproducing analysis was more than half of the cases. So it essentially this was became a sort of gold standard for understanding what was happening. And so some of the data actually were feasible to replicate. So, but if I know this specific graph, and there are points that are not in the right place, so I don't understand why there are 150,000 points, and then some of them are not in the right place, right? But mostly we can say this is a almost perfect replication. On the other end, there was a paper in which we just tried to follow the author's criteria and fill in wherever we couldn't. And we found much less transcript eligible for discriminating cases from control. much less means 120 instead of 160. And within them, the significant ones were, again, were much less, so proportionally, just we were missing part of the story. Okay, so, but also the paper ended up having a very interesting teaching. So whenever the authors were following guidelines for reproducibility, especially Miami standard, that was much better. The chance of this working, being completed was much better. And eventually, that was a very interesting part of the story. The median citation of the papers was much higher for the, let's say, good papers, those that put effort. So in some sense, this is the second thing I would like you to remember. Reproducibility was given in terms of reputation. Okay, so that's automatic. So there was no direct connection. It's just a systemic effect. Another important lesson was working for many years with the MQC team, especially in the second edition, and a huge number of models was being selected by a rather large number of teams, bioinformatics teams, and also on 13 tasks. Some of them were actually blind in terms of where they were random labels. Some of them were, let's say, very positive sample with sex as a label. So we hadn't known for more than 1 year which was the outcome, expected outcome, and that was very important. So we had a number of teams that had errors that were severe. So the dominant factors in having a good balance between what you expect from the development set and what you expect from this left out data set was mainly related to directed to the difficulty at endpoint, but also the tuning of the algorithm, especially the model selection, I would say the feature selection if we want to be more precise, and overall many modeling approaches had error inside. So to obtain a reproducible outcome from different groups, it required substantial effort. So this again is a lesson that I learned. So there were interesting differences between different groups. Okay, so what happened after that? 2010, 2012, there was a number of papers that started automating the search for selection bias, for errors in prediction. So looking for subgroups that were probably influenced by lab effects or other kind of choices in the stratification of the cases control. And then a number of, let's say, decalogues came out, so something like the paper on PLOS computational biology. So essentially, the message is here, do not manipulate directly, keep scripting everything, keep version control, record all the steps. So, and always keep the data. And this is sort of human. So you are a team, somebody may be bound to leave, but there will be one point in your career in which you have to reconstruct. So, and eventually the last item became, as we will see, one of the most important. Provide open access, public access to your everything, which means not only to your data, but also to your method. So eventually, this is sort of complicated, or this is sort of less automated than one would expect. By the way, this is what we are doing now in deep learning. So we are making a terrible mess, trying a lot of models and hoping that with 1 million parameters, something will converge. But we just went back in the past. But so essentially, environment like Galaxy, of course, came out and started giving fantastic help at the point in which the developers could meet with the users. But there are now many interesting things like containers. So Dockerizing your stuff is important. Having virtual environment that can move from different machines and between people. And I would say notebooks are one important solution. There are many frameworks, and now data science is getting connected. So you have an overlay of techniques that have been using also by the team. So when people that are expecting to develop hundreds of models or thousands of models and choose one isn't the other, okay? So I would say the other important element is the convergence towards a science in life science, I would say omics science, which is open. Open as a whole, as an enterprise. So I just citing 2 journals, but there are others that have adopted this kind of approach. I'm citing these 2 because they really adopt it as a, let's say, as a life motive or their as a reason of existence. So GigaScience provided from the beginning tools for storing even very large data set, access to the data, and some kind of cloud computing resources. And of course, Galaxy came out as being one possible use. And the scientific data is a journal which is from the first day is dedicated to giving incentives, giving a small value to scientists that have been publishing a paper which can be a good methodological paper with good results, or a good methodological paper with terrible results, but still the data are good. So still the data can be used for somebody else. So and at one point, very recently, last year, a group of organizations selected a concept that of let's say accessibility of the data as a service to the community, and so this fair principle. So you have to prepare stuff so that others can use. This is a part of your job. It's a part of your organization. So that's the PowerPoint. So we are right to this point. So do you think we are much better? No. The point is that we are not much better. We are probably still in the same let's say, horror cases. So it's going to scale up. It's going to be less visible. It's harder to pinpoint people because they haven't probably provided all the information. But there is still a incredibly low rate of reproducibility, especially in an era where this is fundamental. So especially when a pharma company tries to review studies, they may not even be preclinical, they may even be more basic, and the prevalence of preclinical studies that are not being reproduced is still close in something more than 50%. These are data of a few years ago, but I wouldn't be surprised that they will be still the same. Probably a good pharma making let's say, an interception program is going to find more. So what is the point? The point, we are talking incredible amount of money, incredibly big quantity of money, so this is slowing down everything, and this is slowing down especially healthcare as a global initiative. So the point is that something should be done, right? Okay, so a representative from the pharma industry at the end of last year, or at one point last year, he proposed that yes, we should give prizes to scientists that are spending more time to provide studies that they are bulletproof, they're going to be reproducible. But they say, what about putting also negative incentivation? So we want some money back guarantee, something that, okay, we paid you and the study, you gave us all the data, all the study, we cannot make anything out of it, right? And so we want your money back. Actually, they won't be from me or from a colleague, it will be to the institution. So, but this would be retaliate enough. So this is a very strong position. It's a very strong position because you are the one with the money in your hands. So that's probably moving into the incentivization system, but this is not what we would like to be the world. And indeed, somebody from, let's say, from the other side started saying, okay, this is simply wrong. For the first reason is that you are not yourself following these rules. So there are big cases in which even clinical studies can be reproduced from time to time. But then there is also the point of how difficult is it? Is it completely, let's say, equivalent? Every study is so equally easy? No. To reproduce? No. So it's always a complicated story. So the point is you have to create machinery to remove all the lack of compliance. You have to have fully transparent access to research, but this is okay. It's a position that I would subscribe, but this again, one step back. So we are not talking incentivization anymore. So the point is, we should, at one point, we should take a position. Somebody should take a position, right? So there is an inefficiency in the system, and you need to think in a different way. So you have to think in the terms of ecosystem. So actually, there are the networks of scientists, the networks of funders, the network of pharma. They have their own stakes, but they are combined together. This is the combination of this combination of action. It does not make a good excuse for not creating a solution. So the other interesting part of the story is that the networks are competing. So we are also competing for speed to publication. Some people are in some moment of their life, their career life, they have to publish, even if their own institution are asking to publish. So whatever is the network of the system should also take into account you have to solve these issues. So the point is that, okay, Topol say we need to share everything. So how can we connect together incentivation, trust, and accountability? Okay, and the point is that we are thinking in terms now of institutions. So institutions like entities that are created to take a position in the world and say solve uncertainty. So let's first try to recap what we saw before. So we saw from the oral stories or whatever it was that we can have we have guidelines and we should be following them. We have better reproducibility if we follow the guidelines. Very importantly, reproducibility is given something back to whoever is paying attention. There is a lot of effort. There is nothing that comes by the free lunch. And there is, yes, there should be incentivation. And all along, I would say also negative in order to facilitate this reproducibility, let's say, movement. But first, you have to understand what is happening, what is broken. Okay, so we need entities that can warrant this continuous sharing of assets. And so we need to have accountability, we need to have trust or distrust, which is symmetrical, or incentivation. Okay, so let me go completely to another planet at this point in my talk. And there's the Nobel Prize in '93. Douglas North is now missing, but this was a wonderful way of rethinking economy. And the point is that you have to think in terms of behavioral economics also as a continuous estimation of uncertainty. So whatever we do in our life, we are also taking choices, and typically we are trying to reduce uncertainty. So many things from the very first years of humanity, and now arriving to banks, you need institutions that are creating this formalization. So they could be informal or formal. And of course, the more formal the institution, the more freedom you are losing. You are giving to somebody else. So, but what's happening now? Now we are giving to digital organization. So I would say that the big players like Google and Amazon can be seen for most of their life as digital organization, at least for what is their contact point with us, the interface. So just they are much faster. So they are working as middlemen. So a lot of human activities are now demanded, postponed, interfaced through this online institution. So what is the main point here? Most of these economic activities, or let's just say activities, they have been created like off-the-shelf services. They've been automated. We don't know anymore what's happening, but we are using them because it's easier, faster. So that's the main part of the story. Okay, so that's why we arrived here. So there is this invention, and I don't know how many of you are familiar with blockchain. Any? Can you raise your hand? Wow, wonderful. And is there a miner in this room? Wow, of course. Okay. So that's. Thank you, Oko, for filling this gap. Yeah. Okay. So Oko and also that this guy, also, of course, is a non-existent person because nobody knows who, at least nobody publicly know who invented this. This concept. And the concept is really radically diverse. So the concept is that you start a mechanism that has its own life, is able to regulate the creation of money, the exchange of money, but most importantly, the let's say the trust that is associated to any of the economic activities. And what is incredible that this invention has moved from this specific world to everything. So there is not a single area of human activity that is going to be untouched in the next years. So there are fantastic ideas. Whoever is talking with people in the fintech or let's say insurance, banks, they are investing a lot of effort to be part of this story. Healthcare is going to be one of the major players in that. So it's just a little behind, but it is a very important story. So the basic notion is that there is something which is a database, non-existent database. So it's, let's say, a data structure which is going around the world. It is shared by a very large number, enough large number of computers, of let's say entities. Typically, they can be a single person or network of person, and peer-to-peer technologies are distributing this information. So there are the interesting part of the story is the use of cryptographic protocols, let's say a wide array of cryptographic protocols that are in some area, within some choices, very strongly protecting whatever is the goal of the transaction. So even the name of the person. So there are layers and layers of security. So you are performing something of your interest, and there are no larger organization capable to understanding what's happening, taking care of that. So for a moment, I ask you not to think immediately of darknet, drug dealers, weapon dealers, or pornography, or whatever. Just think of things that can be done. Of course, like in many activities, human activities, there is a space. Whenever there is space for freedom, there is also need to adapt. But this is a very interesting story. So, importantly, there is a concept. The concept of, let's say, ledger is a registry. This registry is continually being created. And I will really recommend this TED talk by, actually, is a social scientist and economist, and she is creating startups and creating a movement or that. So I found it very nice as a generic presentation. I think you can't read the numbers. I can't either, but I want to say the numbers are huge. So let me just try to give a couple of very basic concepts. So you have to think, you may think of money as the object of transaction, but actually you have to think of whatever can be digitalized. So it can be a photograph, can be the certificate of your house, saying this is your house. And yeah? 3 minutes. Yeah? No. You kill me. So I have half a keynote. Okay, so I'm hashing the rest of the keynote. No, I'm going. Okay, thank you. Okay, so there are this asset is going to be verified. So somebody is going to say, I copied with it, right? I didn't fail down. Okay, so there are the nodes of the system, we will call them miners, and they must have a lot of computational power, and I will explain why. So everyone will have a copy of this data set, of this information, and this data set have the history of whatever happened before until now. So there is the past is inscribed into the database. So the miners will try to perform a task. This task is enough difficult to take time to use a heavily computational effort, and while doing this task, they are going to validate a transaction. Actually, not only one miner, but a number of them. Once, let's say, a threshold, a magic threshold of 610 or whatever it is, the current state of the system, the transaction will be validated. So once it's validated, you store it permanently in the blockchain. So this is I want to say, this is a general mechanism. It's not just the Bitcoin story. Each blockchain then has been characterized, specified. So now we know that Oko in this room could be somebody in the happy team on the right. So there are actually very big players. So you have to think that the community has already overpassed the computing power of Google. I don't know for Amazon too. They are using specific hardware solutions that are optimized for not destroying too much energy, but essentially for being faster, because you are competing with the others. And mostly unless you are a super team in China buying the number 3 supercomputing center this year, you have to cooperate. So there is also a sharing of gains and time and cost. And the point is that to reach this, to solve this computational problem, called also proof of work, which means I have the one who is going to place the next block in the blockchain, and I will get this money. And I have to specify that. So I'm getting rewards, and these rewards is actually new money being created. For Bitcoin, the timing of the system is parallel to the how much gold is being mined in the world. That was a sort of one has to take one decision, so that was one possible decision, and there are things that are being changed. Okay, but you have to think then you have a lot of options, like you start creating the money, how you adapt to the complexity, so you move the complexity of the task to go faster or slower. And the point of the complexity is that you don't want too many miners to agree together to have because they could forge a solution. They could take a decision and instead of validating a real transaction, put another transaction at the point. So the dimension of the system. So so if you open any on the airplane or wherever one picture of blockchain, which typically be the same. Okay, I remember Margherita. Okay, so if you see, you start from A, so somebody is trying to create this block from A. There is a transaction. This is what I want to become purple there. So you want this purple block to be validated and inserted in this sort of cross. This is actually a big tree. And put inside that. And for doing that, you broadcast your request to a network. This network, nobody actually has control on this network. So it can be any part of the planet wherever there is energy and money for running that. So the validation, when there is an agreement, so a number of nodes will win and they will validate the system. So what is actually achieved? There is a validation by, let's say, population, so by consensus. So in an ensemble, what's coming out, which is one of the best solution in machine learning came from that. You create immutability, so whatever is inscribed in the blockchain remains forever. So you cannot change things. So I cannot sell a car to you and then change my mind and say, no, I didn't want. Oh, that's happened forever. So this is very different from even working with your bank, right? You can trace whatever is happening in the process. Also, there is some obfuscation of who owns the process, and there are possibilities for making this completely public, very private with permission. Okay, so that's but essentially the transparency, the sharing is built in. So when people trying to see in that a new way of thinking. Are saying, internet happened to be a medium for information. Blockchain is born being the medium for value. So this is going to happen to give very profound changes in society. So the other very interesting part of the story is that enough recently, another ecosystem has been launched called ETHEREUM, and ETHEREUM is using the concept of smart contracts. So smart contracts are actually programs. So this is not only a platform, it's a programming language. In this programming language, you are sort of inscribing what is going to happen in the future. So it's not what is happening now. So you can put, this is also possible within the Bitcoin, but was much more difficult and limited. So the applications are unbelievable. So the point is that a contract is actually a system of rules, right? When you write a contract, you're actually writing rules. So the contract accounts are these autonomous agents. They are sort of, they are completely autonomous once you launch. So start twice, think twice before getting a killer with a smart contract, because there is no way to stop it, mostly. And they can read and write, create other messages. And essentially, you start creating an agreement, which is okay. So something like, I'm going to buy your car, but I want to try it first. I want to check it for 1 day. After 1 day, the car will be yours unless I want to return it. So that's, and this is, we do not require lawyers, police. It is just maintained by the system. So my transaction will be cancelled if you don't comply with what we did. So there are directions. One direction is that there are several cryptocurrencies. So beyond the Bitcoin, Ether, which is the one of the potential of the Ethereum, there are a number of different currencies. For instance, Monero is specialized in completely protecting the anonymization by using a different type of encoding by crypto. And on the other hand, Ripple is creating layers of information together being exchanged. But so things like we are going to, most likely, if we are going to share a car in a few years, we are going to use this kind of system. So the system will take care of responsibilities and advantages of using a shared good like a car. Financial services, voting, which is a very hard thing, point to pass, but it looks like it's much better to do to some digital entity the management of your security of your votes, and healthcare, of course. So what are we doing now? So we are trying. So we started thinking about it. We remember the first part of my talk. So the point is, how can we use a blockchain-based mechanism to make, let's say, the big bosses disappear? So we don't have anymore, we are not thinking in the first place that somebody will take care of us. So the institution should not be NCI, should be, or the police, or whatever police you want to imagine. There should be something built for us and that we decided to use. So now what I'm going to describe is an idea. So we haven't implemented it. Would need some money and a lot of collaboration. But this is the kind of stuff that society like the MakeUC society could adopt. And I'm pretty sure some of the society taking care of data accountability and data sharing will adopt it. So it's a matter, I was saying, most likely our concept is not completely solid, but we wanted to present it today because this is a good place to start with. So we called it probo, which is a Latin word, is actually for provare, to try, to test, and is also so we even have a money, a coin. We will call that probos. And the point is to create something which is resilient to fraud, which is traceable, transparent, and trustless. So, and by doing that, we're finding a way for ranking people for their adherence to these principles. So, again, a lot of details are missing. So, to create this system, first I have to tell you that we need a blockchain, so a ledger, this database where the results will be notarized. Second, we have rules that will be sort of different. So we will need to create these coins. We need mining agents, and we have an approach. So the approach for us is aimed at incentivizing evaluation by peers. So you may have read something in the area until now. So somebody saying we should use a blockchain for tracking documents. So you can create an hash of whatever, any data set of any picture, graphic you have done, and you can put together other hashes, and this is sort of a memory. It's like, you know, when you want to protect an idea, but this is something different, what we want to do. So let's say that we have a proponent, so it is a one node, or they could be collaborating, I think we could manage that, and they want to have their scientific work validated for reproducibility. So the most likely there are data and data to be analyzed, and somebody else should reproduce it. The first thing you have to do is to define your input. So you have to define a collection of data, and this will be time-stamped. The software, the mythos, whatever, and most likely a connection to a GitHub with a versioning number, so they will be encoded into the system. At this point, you also create your results, and you hash these results. So you create a version which is from which is very hard to come back, and it's a good idea that is also put inside the parameters like the expected amount of time. So it should be something which is close to you, to something with your resources, and also some, let's say, some threshold for staying into. So we know we are talking life science, so we could have not imperfect but very close replicability. So the proponent is creating a block request, including all the inputs, all the hashes, and broadcast it in the network. So you see, it's not very difficult, very different from what we see for the money. And of course, you could also at the same time send it to the publisher, provided the publisher is already into the network. So now we need somebody to verify it. So the verifier will be other nodes that will decide which request is worth accepting. You can even be unable to doing that, but so you are based on your skills, assessment, quality. And each verifier will use the same data or the same version of the software, the same method. So everything will be also checked, and will produce an output. This output, by a number, not too big in this case, I guess, will be compared with your hash. So if a number of verifiers accept the request and they can also validate it, they will create a new block. So this new block is now doing something wonderful. So it's creating new money. So it's creating, let's say, points, tokens, but it's really money. So if you, for any of the coins I was describing before, you can go to an exchange system on the web. You can get Bitcoin if you have the most funny type of coin, but you can also get the euro. So you're thinking this is really creation of new money, a creation of rewards. If you have, everything went okay, your deposit, because you left some money there as a deposit, because we don't want people to just submit without any without any hope to get it. Otherwise, you lose your money. But what's interesting, together with the deposit, the reward, whatever, we are tracking everything. And this story is forever put into the system, for the good or for the bad. So you start having a record. You start having a record of being very good in replicating somebody else. You start having a record of being very good at offering good research. Okay, so this is very the collective part of the story. So again, you start. Suppose that the researcher she has been able to assemble together the data, the software, the methods. She can also put her own personal key for cryptographic key. The verifiers will choose, create a blockchain, and this Bitcoin is going to be generated. So what are the byproducts and what are the products? So we think that, I think this can be really create a new set of stimuli. And some of them will be for activities dedicated to reproducibility. Some of them will be an evaluation of ranking or reputation. So that's it's pervasive. So we don't need somebody to define an index. We just collect the results, and of course this is going propagated to our institutions or to our growth. So the failures are also accounted. So you have to be careful if you want to underline to that. So the opportunities of being ranked by the score, the reputation score, can be also propagated to the system. So this could be one possible decision. So you have an ecosystem, and the ecosystem is funny, it's trustless. We don't believe you because we have to think you are a good researcher. We believe you because of your actions. And I mean, even if you are starting creating fake papers or creating cartels of paper, this will be revealed by the system, I think. If you are a journal, you should start matching how much you are accepting or rejecting of papers that have been accepted or rejected by the network. And an intriguing part of the story is that I would start having some specialists or putting PhD students in rotation for doing this job, because they would generate money. So you are generating money for them, for my lab. There should be a tactical time that you put into that, and but you get money, so you can change that. So that's you can fund your research. So you're a student, first year, you make exercise. Instead of doing exercise which is probably not so strongly related to your project, you're accumulating money. I see a number of potential of that, right? What I want to say is that I probably in the short time I couldn't really convince you of that, but the amazing part of the story is that you can sell your music, you can create collaborations by use of blockchain in other areas. So it is totally transparent. So we don't need to share trust, because it's the system that is creating this institution. So I think it is much better of some ideas that arrived before, in which there were operations for reproducibility, in which a group of scientists said that we are going, if somebody puts money here in the pot, let's say a charity, we are going to do something. And eventually they ended up fueling, let's say, community laboratories. So ironically, these laboratories would stay much better if they would send the results to the preferred pharma company without telling everybody. So the science globally would never proceed, because more errors, more money for the labs. So this is a sort of game. So also I think we are reusing everything from the association from the organization that have been fighting for standards, because we just have to put the compliance to the standard into the request. So that's there is no competition here. It's just adding strength. This is actually different from a couple of ideas which are much more I'm encoding. So there are a couple of, this is amazing because this blog actually has never been published, and there have been a paper citing that replicated the same concept. They tried to publish of F1000, and so some reviewer spotted. So a paper about integrity was replicated this concept without citing the authors and making some mistakes. So that was retracted. So there was a paper about the machinery against for retraction. So that was amazing. And so there are also other concepts, let's say, in the computer science community. So I'm going to conclude now. So there are plenty of details. So I'm lucky to be collaborating with some guys that are doing very interesting things with multi-layer networks. In multi-layer networks, there are new findings. I discovered that ideas in behavioral economics are probably wrong, because so there is this excess. If you do experiments with games, typically people are selfish, but in real life they are not so selfish. This is because real life is a multi-layer experience. So we decide things according to different to different needs we have. Some of them are social, some of them are economics, and whenever there is this combination, there are more ways in which a strategy can evolve. And eventually, so there is a lot of cooperation, much larger than expected, which can be good or bad. Yeah, it can be bad because we need to test such networks. And in order to avoid that groups can connect, and so a group of rich miners, let's say in this case, can start getting more resources, getting more power, then arriving to the point they can even accept the wrong paper because it is from their cartel. So that's something to do. And even if I said I'm not going to talk about deep learning and AI, eventually, of course, we are going to have to deal with that. So most likely this validation can be, we could train systems. Okay, and I'm not saying that our PhD student will lose this fund. Probably they will graze the robots. But it's very likely that we are going to have machines that are going to do this job faster, probably more accurately once the thing gets started. So they will get reputation. We have a very fresh archive. So fresh means a couple of days. And feedbacks are really welcome. So we are receiving from the community some interesting comments. So please have a look and we will be happy to get insights or comments. So let me conclude. Mario Domenico, Giuseppe Jurma and Nicole Bussola, they've been collaborating in this paper, especially Mario for the starting the concept. We think we have already put into the system a rather fairly rich set of options for, let's say, feedback mechanisms. Some of them are explicit, some of them will probably emerge, and they will be combined very easily with standards and methodologies that we have already agreed that we want to follow. And we expect that, I don't know if we will ever see this kind of system, especially done by us, but I think that this kind of solution can touch a very wide set of networks in existing practice. So I think something like that will really be useful for open science, for reproducibility. So thank you for listening.
That was fascinating talk. Questions?
That's very interesting what you're talking about. I was just wondering about one potential problem. So as you know, in Bitcoin, if you put a wrong transaction in the block, the other members of the system won't use the block and you will essentially lose time, right? So in Bitcoin, you have incentive to do a good job, otherwise the other people will ignore you. In this system, it seems that you can do a bad job verifying or disproving, let's say, someone else's work, and you will get the money anyway, and there is basically no way to check. You say that there's reputation, but even if there is a reputation, you still got the money, right? So there is a very big incentive of not doing job properly in the system. So.
Yeah, we're working on that, and definitely this is the reason why I mentioned the game theory part of the story. So you need to put something which is actually a second layer of information. So there will be the minus one side and the flow of information with the verifier. So there will be a validator of the network. This is what is happening in the Ripple system. So there is a doing between network banks. So. But we absolutely have this problem. It is a fast comment we got from the right. Thank you.
Well, you answered the next question. Can you go back one slide to the paper? Thank you.
So my question is about the different levels of verification. I mean, especially if you look at peer review as a fairly low-level verification, and you can start looking, does the data look okay, or replicating everything, and then trying to generate some of your own data to see if the results hold. So you really have different levels of verification that can happen. Does this system is able to handle that? Is that a feature that you'd want to be able to handle?
So first I would say that I would like not to put limit in this sense. So I would not say this is just for perfect replication. I show you one picture from the past in which I had 100,000 points and something not there, but was less important than some other disaster. So I would say we put actually in the probably I went too fast on that. We put so you would also put the confidence interval, say, of your results. So at the time you should have to achieve that. So definitely this is part of the system.
So kind of a related point, and that is that you also have a problem with people submitting things for verification, because do you envisage putting a minimum sort of minimum unit of information that could be submitted? So if I make a simple graph and I submit it for verification, that produces some coins for someone, but that's a very different amount of work to both to verify and potentially to reward than a whole study with a paper and a whole bunch of graphs. And so you can imagine people might submit an awful lot of small things, and that ends up rewarding people disproportionately to people who then submit whole papers or whole studies.
Yeah, so I think the answer, we thought a lot about that. So the answer is that it's wise to split the tasks because of the time, because we have to put we need to have a constraint. While the Bitcoin is paced, we need to find a pace for research, which is probably associated to your need to be out with a paper or something like that. So if you can split a task, I would split the task, but you have to pay for it. So if you are going to be very good and splitting a lot of tasks, you can put aside the money. We're happy with that.
So if you put in a whole study, you'd put more coins down.
Yeah,
than if you put in a graph, you'd only put half a coin down.
Yeah, so if you split in 5, you're going to pay 5 times.
Okay.
So this makes, but you know, it's more subtle, but this is the main point.
Hi, I think you just answered my question, but I'm just asking again. So even if there are no malicious users in this system, remember in cryptocurrencies that there is always a difficulty level, right? So it gets harder to generate more coins. But even if there are no malicious users, you just keep printing money, which is going to devalue the coin. Did you think about increasing?
No, actually. Okay, so there are 2 points which are overlaying. So again, in the Bitcoin, another solution, they did something very different. There is a pace, so there is a balance. If somebody enters in the game with a lot of power, things are becoming more difficult.
Yeah.
So that's continuous balance. So you can create more blocks.
So in this system.
So we have to put something like that, similar. The very big issue is that we cannot accept to have so many verifiers. So that's our limit. So we are not. There are not so many groups.
There are robo validators.
Yeah, the robots. Yes, that's the solution probably. Yeah. Thank you.
Any other questions? If not,
so I was wondering, how do you actually get the journals involved or on board on that? Because so far, the entire process of publishing something in a scientific journal is they're sort of doing that job, or they're meant to do that job, which they're apparently not doing so well. So if basically the validation of scientific work is done by other scientists, that sounds surprisingly familiar, like the peer review model. So if we do it online, what is the role of journals then? And don't you think that these will perhaps try to prevent an independent peer-to-peer solution like this? Or what do you see the relationship? I mean, do you think journals will coexist? Can you get them on board, force them on board? What's your thoughts, journals versus
So
this?
I would like to think, I like to think that we are solving a problem for them. So we are creating a machinery which is self-standing without require their own intervention. All the rest of the journal, I mean, reading the paper, understanding the methodology in the sense of clarity, novelty, whatever, will remain with humans. We are talking about the thing that nobody is doing. So unless, even scientific data is not requiring to replicate everything, so describe whatever. So actually we are solving a problem. So I would say they may use. The point is what happens once you count after a couple of years. You discover you accepted all the rejected papers, and you rejected all the very good methodological papers. That's but that's another matrix. We don't want to create it. It happens to come out.
Do you think there's that we're doing anyway in the system?
Well, unless you believe in a super intelligence, reading your mind while you think a new idea, I would say yes, we need an institution called publishers.
Great. One more question?
Sorry, one more. And what would happen with small mistakes?
Yeah, I said that was my first point, and so we have threshold to accommodate. So only you have to forecast them. So you have to decide if it is what is acceptable for you. So I would put my own confidence interval, and I would ask for them to do that.
Yeah. Any other questions? If not, let's thank our speaker again.